Okay, so this is the 2008 multiple choice test. I'm going to sort of try to do a speed run to go through this as quickly as possible. Okay, so we have the limit as x goes to infinity. The key to this is we're going to have to expand these. Okay, now it's clear. All right, so I'm going to expand the top. I'm going to just FOIL. I'm going to get 6x minus 2x squared minus 3 plus x. And that is all going to go over, I'm just going to FOIL the bottom. We get x squared plus 2x minus 3. So we look at this. This is the limit as x goes to infinity. As x goes to infinity, all we care about is the highest degree. So I see a negative 2 here, and I see this one here, negative 2x squared over x squared. That's all that matters, okay? When the degree is exactly the same, it is just the ratio of this to this, which is negative 2, so it is b. You need to know that. If the higher degree was on top, it would have been infinity. If the higher degree was in the bottom, it would have been 0. Okay, moving on. So 2, we've got 1x squared, so we have an indefinite integral 1 over x squared. Okay, so I'm going to rewrite that. I'm going to say, well, that's the same thing as this indefinite integral right here. So all we need is an antiderivative, no big deal. I'm going to add 1 to this. I'm going to get x to the negative 1, however, over negative 1. Remember to do that for sure. Plus c. So then what does this become? Well, let's see. This is the same thing as negative x to the negative 1 plus c. Hopefully that's one of our answers. We look up here, and there it is. It's d. Boom, done. Okay, so let's see what we get next. C. All right. Okay, so we just need a derivative of this. Looks like we have a couple things going on here. We got a product rule. We also have a chain rule. So let's deal with it piece by piece. I have this function times this function. Product rule tells us derivative of the first, that's just 1, times the plain old second is all of this garbage. Okay, now I'm going to add the first function. Okay, now I need the derivative of the second. So that's to the third. So the 3 comes down. X squared plus 2 squared. But now I need the derivative of all the garbage in the middle because of the chain rule. So that ends up being 2x. Okay, it doesn't look like any of our answers, so we have to clean it up. So this is what I get. I get x squared plus 2. You can't see that. That's so annoying. I have to restart. Okay, so this is a sort of a speed run of the 2008 multiple choice test. I had to redo it because something wasn't showing up, but whatever, that's not of interest to you. Okay, so I'm going to do this as quickly as I can and as clearly as I can. Okay, so here we go. I've got the indefinite integral of 1 over x squared dx. Okay, I'm going to rewrite that in a way that's a little more congenial, something that I like. Looks like that. Okay, antiderivative of x to the negative 2, no big deal. I'm going to add 1. I'm going to get x to the negative 1. I'm going to divide by negative 1. Plus c, of course, because it's an indefinite integral. This becomes, let's see, negative x to the negative 1 plus c. We really hope that's one of the answers, and it is D. Okay, so the idea of this is you can pause it or go back if you don't understand what I'm doing. I'm just going to go fast. Okay, next thing. 3. You can see I started this one, but then I realized it was going outside of the page, so I stopped. Okay, so f of x is this. We want f prime of x, which is just the derivative. Okay, a couple things. First of all, product rule. So let's deal with the product rule piece of this. Product rule says derivative of the first, which is just 1, times the plain old second, which is all of this stuff, x squared plus 2 to the third, plus the plain old first, which is x minus 1, times the derivative of the second function here. Derivative, this is going to be chain rule. The 3 is going to come down, and it's going to be 3 times whatever's on the inside, x squared plus 2, that entire thing squared. Don't forget chain rule. Derivative of the garbage on the inside is 2x. Okay, well, that's the answer. Well, it doesn't match any of their answers, so let's mess about with it. I'm going to look and see what I can do. Okay, so this is x squared plus 2 to the third. Let me mess with this a little bit. This looks like 6x times x minus 1 times x squared plus 2 squared. I'm just doing a little bit of algebra. Okay, looks to me like over here they yanked out an x squared plus 2 squared, so I'm going to yank out of this entire thing x squared plus 2 squared. Now I'm going to have brackets here. Well, I yanked out x squared plus 2 squared, leaving me here with an x squared plus 2. I yanked x squared plus 2 squared out front, so that leaves me here with a plus 6x squared minus 6x. And is that starting to look like anything? No, not yet. We need to do one more step. This is actually just an annoying piece of algebra. So I'm going to clean up everything on the inside. X squared plus 6x squared, that's 7x squared. Minus 6x doesn't go with anything. Plus 2 does go with something. Here we go. We cross our fingers. Hopefully that's one of them. Boom, it's D. Done. Okay, next one. We have an indefinite integral. Okay, so important thing here, anytime you have an indefinite integral of two things that are being added together, you can take each one individually. So I'm going to say to myself, all right, well, what's the antiderivative of sine of 2x? Okay, you have to know the antiderivative of sine is negative cosine. So this is negative cosine of 2x, but keep in mind, we have to compensate for the chain rule. Okay, so I'm going to put the entire thing over 2. Now, what I would advocate is if you're not sure, check, take the derivative of this, make sure it matches that. It does. Okay, antiderivative of cosine of 2x, well, it's going to be sine. of 2x, and then same deal, all over 2. And then because it's an indefinite integral, plus c, which you can kind of see, but that's okay. So let's see. So I'm looking at all of this garbage, and I'm saying to myself, well, this is negative 1/2 cosine 2x plus 1/2 sine 2x. Well, there it is. It's b. Boom. Done. All right. Next one. I have about 4 minutes to go. Okay. Okay, so you can see that. All right, so this is the limit as x goes to 0. So we say, oh, got a limit, piece of cake, just stick in 0. Stick in 0, I get 0 over 0. Okay, now we could do this the way they want us to do. Come on, stop being blurry. We could deal with this in a way that they would want us to, but there's a better way to do it. And anytime you're trying to take a limit, and I'm speaking extemporaneously while I wait for this thing to clear up, which it just isn't doing, but that's okay. Anytime the limit, there it goes, the limit is 0 over 0, you say to yourself, aha, I know, I can use L'Hopital's rule. So L'Hopital's rule tells us, well, take the derivative of the top, that's going to be 20x cubed plus 16x, and the derivative of the bottom, that's going to be 12x cubed minus 32x, and now plug in 0 again. Plug in 0, wait, it's still 0 over 0. That's fine, L'Hopital it again, okay? I'm going to take the derivative of the top, 60x squared plus 16, all over, let's see, 36x squared minus 32, okay? Now I'm going to plug in 0, so that becomes 0. That becomes 0 as well. Oh, we're left with 16 over negative 32, otherwise known as negative 1/2. Boom, done. Okay. So let's see, 6, let f be the function defined above. Which of the following statements about the function are true? That's the end. There's a question mark there. I know you can't see it. All right, so I'm looking at this function, and okay, so you can even start thinking about it like this if you want. So it says if x equals 2, okay, the function is worth 1, so I know it has a point there, okay. Now, it's all of this garbage whenever x is not 2. Okay, so let's see. Does it have a limit at x equals 2? So in order for it to have a limit at x equals 2, let's see. The limit, if I plug in 2, I get 4 minus 4 over 2 minus 2. Well, that's 0 over 0 again. Looks like another L'Hopital's rule situation. So I'm going to L'Hopital it. I'm going to get 2x over 1. I'm going to plug in 2, again, the limit as x goes to 2, and I'm going to get 4. Okay, so it does have a limit, and the limit happens to be 4. So that means 2, 3, 4. That means whatever the function looks like, it's going to be approaching 4, like that. So it has a limit. Is it continuous? No, because it has a point at 2, 1, which means we'd have to lift our pen, so it's not continuous. And if it's not continuous, sorry, no chance it's differentiable. It is going to be A. Okay, we're done. Let me just say one more thing. Okay, for something to have a limit, the left-hand limit and the right-hand limit have to be the same. That's another, perhaps easier way to think about it. All right, I'm going to see if I can get like one more problem. Okay, let's look. Particle moves along the x-axis with this velocity here for time when greater than 0. If the particle is at position x equals 2 at time t equals 0, what is the position of the particle at t equals 1? So let me think for a second. So I want to know the displacement. I basically want to know, well, how far did this particle not travel total, but move away from where it started from t equals 0 to t equals 1? Okay, so that's displacement. If I want displacement, I'm going to say to myself, okay, I want to take an integral from 0 to 1 of the velocity. That will give us the displacement. So here's my velocity, 3t squared plus 6t. Okay, so this is the total displacement, and you need to know displacement is an antiderivative. So I'm going to say, well, let's see, the antiderivative here is, looks like it is going to be t to the third plus 3t squared. Okay, I'm going to plug in 1, and I'm going to plug in 0. So you need to be able to set up these definite integrals quickly and easily. So I'm going to plug in 1, I get 1 plus 3, that's 4. Okay, I'm going to plug in 0, 0 plus 0 is 0, equals 4. Oh, wonderful, I'm totally done. The answer is 4. No, read the question really carefully. Okay, it starts at time t equals 0, it starts at 2. Now we want the position at 1. Well, the displacement is 4. That's not where it ends up. That's what the displacement is. So it started at 2. The displacement was 4. That means it started at 2. It was like, oh, hey, I'm here, if you can see that. And then it went over 4 more. So it ended up at 6. Boom, B. All right, that's 9 minutes. I'm going to stop here and then do the next one next.